All right, so the last couple that we've got, we have if a dollar is deposited in an account paying 12% per year compounded annually, after T years, the account will contain, and then we have Y equals 1, which is your original dollar, plus 12%, and then we're going to raise that to the value of T, which is the number of years. Okay, so I can simplify that by saying Y equals 1.12 T. And what we want to do is fill in a chart. So if T is 1, 2, 3, 4, 5, or 6. Okay, so all of them are done for me except for 3 and 4. Okay, so if I fill in a 1, it gives me 1.12. If I fill in a 2, it gives me 1.25. Okay, if I skip 3 and 4 because I don't have my calculator yet, this gives me 1.76, and number 6 gives me 1.97. So if I start with a dollar at 12% interest, I'll have almost $2 at the end of 6 years. Well, now I've got to evaluate at 3, so I'm going to do 1.12 raised to the third power. So 1.12 raised to the third gives me 1.41, or I'm sorry, 1.40. Okay, and if I shove in a 4, that gives me 1.57. 1.57. So then it tells me to graph it, meaning I'm probably going to plot it. Okay, so what is our base? Our base is improper because it's bigger than 1. And so he will cross at 0, 1. And then the 0.1 comma base is also on there. So this thing is increasing, but boy howdy is it doing it slow. Because at the 0.6 comma whatever, it hasn't even gotten one more point. So it looks flat-ish, only because it's really, really, really close to 1. All right, so we've got number 10. So you are going to, all right, if this is good, it's about textbooks. All right, so if you lose money, if money loses value, then as time passes, it takes more dollars to buy the same item. So use the table to answer the questions. Let T be in years and let Y be the value of $1 in T number of years. So in other words, look at the American dollar. Let's pretend like it's worth an actual dollar this year. Well, in 1 year, it loses its value. So now it's only worth 96 cents when you compare it to other people's economies. Okay, so we actually have to use more of our dollar to purchase what I could have done for $1 this year. All right, so suppose a house costs $114,000 today. I want to estimate the cost of the same house in 4 years. So how am I going to do this thing? I need to actually figure out what my equation is. All right, so we would think that you could do 114,000 times 0.85 because that's the value that we get here. But that's not what's going to happen. Because when we do that, we find out that we get $96,900. Well, we know that it's going to cost us more in 4 years than it does right now. So our other option is we can set it up as 114,000 divided by 85%. Okay, when we do that, we get, divided by 0.85, is 134,117. So $134,118. Okay, if you round it to the nearest dollar. Now, all that means is what was 114 is now 134. So if you wait 4 years, you're going to have to pay $20,000 more to buy the house. That's if your dollar is losing value. So what happens? What if we want a $50 textbook today and we want to know the price in 5 years? So a $50 textbook today, and in 5 years, it's going to be divided by 0.82. So what I have is 50 divided by 0.82, and I get $60.98. So $60.98. So it's gone up $11 in however many years I just said, 5 years. It's gone up $11. So that's another way that you can use exponential functions. For the last one, all right, you can use this equation. So we have the assets in billions of dollars for a financial firm can be approximated by the function. So I have the assets are 320, E, which is a number, not a variable, and then 0.039 times X. And X equals 7 corresponds to the year 2007, which means X equals 0 will correspond to the year 2000. Find the assets in each of the following years. So in 2010, and then again in 2015, and then again in 2018. Okay, so if X equals 7 corresponds to 2007, then we're going to do X equals 10. So this will be 320 times E raised to the 0.039 times 10. And this one will be 320 times E raised to the 0.039 times 15. Okay, and this one will be 320 E to the 0.039 times 18. So when we put that in our calculator, we end up with, clear. So 320 times, you have an E button on your calculator. Okay, so times E to the 0.39 times 10. So that gives me 472.63. So 472.63 billion in assets. Well, what happens if I put in a 15? So I get 574. $574.40 billion in assets. And what happens if I put in an 18? I get 645. So 645.69 billion in assets. So these are ways that you can use exponential functions. And just to come back to this one, we could have made an equation for this one, but we didn't need to because the information was here. We could have made the equation, but we didn't because they gave us the information that we needed.